Welcome to The Explainer. Today, we're pulling back the curtain on one of the unsung heroes of the entire AI revolution, the vector database. It is, and I'm not exaggerating here, the secret engine that powers so much of what you see, from chatbots to image search. So, let's break down how this whole thing actually works. All right, let's just jump right in with a question that gets to the heart of it. You know, when you're talking to an AI, how does it seem to grasp the meaning of what you're saying, not just the literal words? And how does it connect what you said 5 minutes ago to what you're asking right now? Well, the answer to that question reveals this huge fundamental problem in the world of AI. It all comes down to the type of data that these models need to thrive, and the simple fact that, our old tools, they just weren't built for this job, not even close. What's so fascinating is this massive mismatch in technology. For decades, databases have been absolute champions at one thing: organizing data into neat, tidy rows and columns. Think spreadsheets. But AI has to make sense of our messy, complicated human world, all that unstructured stuff like text, images, and audio. And that kind of data just doesn't fit into a box. And this right here, this slide just lays it all out perfectly. Old school databases are all about exact matches. You search for the word cat, you get results with the word cat. Simple. But vector databases, they're playing a completely different game. They search for what's called semantic similarity, which is really just a fancy way of saying they search for meaning. So you could search for small, furry household predator, and it could bring you back results about cats. It's a total paradigm shift. So, to deal with this brave new world of unstructured data and searching for meaning, we needed a completely new kind of database, one that was designed from the ground up specifically for what AI needs to do. And that brings us to the vector database, or VDB for short. It's a really specialized system that's built to do one thing incredibly well: handle these things called vectors. Just think of a vector as a long string of numbers, like a mathematical fingerprint that perfectly captures the essence, the meaning of a piece of data. The VDB's whole job is to manage literally billions of these fingerprints at lightning speed. And what that really means is that VDBs are tailor-made for AI applications. They're incredibly fast at finding vectors that are similar to each other. They can handle pretty much any kind of unstructured data you can imagine. And, crucially, they're built to scale to absolutely massive, real-time datasets without breaking a sweat. Okay, but this is where it gets really cool. This is the magic. How in the world does a database find things that are similar in meaning if it's not just matching keywords? The process is actually pretty brilliant. I love this analogy because it's just perfect. A traditional search is like going through an old card catalog looking for an exact title. A vector search, on the other hand, is like asking a really smart librarian, one who understands the concepts inside all the books, to find you everything related to, say, giant, mythical, fire-breathing lizard. It all kicks off with a process called vector embedding. You have a special AI model that acts like a universal translator. It takes a piece of text or an image or even a sound, and it converts it into that mathematical fingerprint, that vector, that represents its core meaning. It turns everything into a common language that AI can understand. So once everything is turned into a vector, the database needs a super fast way to search through them. I mean, going one by one through billions of items, that would take forever. So instead, VDBs use this really clever shortcut called approximate nearest neighbor search. It is built for one thing, and one thing only: pure, unadulterated speed. So here's the simplified version of how it works. First, the database creates this kind of map, where it places similar vectors close to each other in neighborhoods. Now, when you do a search, the VDB doesn't scan the entire map. No way. It instantly jumps to the right neighborhood of related concepts and only searches there. The result? It finds the closest matches in just milliseconds. So, how does this amazing technology connect back to the generative AI boom we're all seeing? Well, it turns out that vector databases and large language models, LLMs, are basically a match made in heaven. The most important way they work together is through a technique called Retrieval-Augmented Generation, or RAG. This is a game changer because it helps solve two of the biggest headaches with LLMs: the fact that they can just make things up, that's called hallucination, and that their knowledge is basically frozen in time. RAG gives them a direct line to fresh, factual information. This workflow is absolutely key. Before an LLM even tries to answer your question, it first pings the vector database to pull out the most relevant, up-to-date facts and documents. Then it uses that specific retrieved information, that context, to build its answer. And that makes the final response way more accurate and trustworthy. And it doesn't stop there. VDBs also act as a kind of smart memory for LLMs. They can cache answers to similar questions, which saves a ton of money on expensive API calls. They give the AI a reliable long-term memory, so it can actually remember past conversations. And, this is huge, you can update the knowledge in the VDB anytime you want without having to do a costly, time-consuming retraining of the entire model. So, as you'd probably guess, a technology this important has absolutely ignited a super competitive market. We've got a whole ecosystem of companies and open source projects all racing to build the best, fastest, and most powerful solutions. And the market's really diverse. You've got these specialized, cloud-native players like Pinecone and Zillis who offer managed services that are super easy to get up and running. Then you have heavy-duty open source projects like Milvus and QDRANT that give developers a ton of control. And you've even got extensions like pgvector, which cleverly add vector search right into traditional databases. A great option if you're working with an existing system. Okay, I know this chart looks like a lot, but trust me, the story it tells is actually pretty simple and super important. There is no one-size-fits-all winner here. Just look. Yeah, Milvus does great overall, but check out Zillis Cloud over here in red. Its latency is crazy low. That means it's unbelievably fast. Perfect for anything that needs a response like right now. But then you've got Weaviate, which shines in recall. That's how accurate it is at finding the best stuff. So it's all about trade-offs, right? You have to ask yourself, what do I really need? Is it pure speed? Is it pinpoint accuracy? Or is it something in between? But hey, the work is far from done. This field is still wrestling with some enormous challenges. I mean, how do you scale these things to handle not just billions, but trillions of vectors? How do you get them to handle even more different types of data, all mixed together? And of course, the big one, how do you make sure all this data is kept secure and private? So, let's just tie this all together. At the end of the day, vector databases aren't just some new, fancy type of storage. They are a fundamental shift in how computers understand information. They're the critical bridge between the messy, chaotic data of the real world and the AI models that are finally learning to make sense of it all. And that leaves us with one last big question to chew on. As pretty much all of our data gets more complex and less structured, is this technology just a niche tool for AI? Or are we actually witnessing the beginning of a future where every database will need to understand meaning, not just exact matches? Something to think about. Thanks for tuning in.